So, just to remind our goals, in our practical example, we chose to make contact form with calendar booking slots. And in the previous video, we've managed to complete server-side APIs. I did my best to make this video quite brief, and while the next one will focus on actual client-side programming, this one will help us summarize what we need before start thinking of that implementation. Probably this is the first place in the video series where I don't write code from scratch and instead taking something previously created, talking more about goals and high-level thinking instead of details of implementation. So here comes one more crate in our workspace called server macro. And from the name, I hope it is clear that it just contains some macro declarations. As this crate contains macros, it needs to have the special attribute in cargo TOML. And scene dependency should be downgraded to the first version, as the code I just copy-pasted was written a while ago. Now we can add our new crate to be a part of the server package prelude. And here comes its usage, because now we have derived macro open summary that we can apply to our API documentation structure. There could be some attributes, what to join into one structure or what to skip. And now I'm declaring more command line arguments from which you can probably guess what had just happened and why we needed it. Now, in runtime, we are adding a command line option to get our OpenAPI schema, build some summary in command line terminal, or, what is more important at this step, automatically generate client functions in Rust language, which will be wrappers of all our API requests. Well, we still need to fix a few typos and missing dependencies before moving forward. It looks like we're missing JSON serialization dependency. And the ability to make terminal output in color with error package. Now, as you can see, we launched the summary of our API in terminal, and it actually highlighted some errors in a protocol declaration from the previous parts. The summary and visual check of API looks good. Let's move towards creating client-side code for requests. We need dependency for request, and we also need to define what our response structure is. That part was just copy-pasted as well. And this is the desired auto-generated code in Rust. It will take us a few more tweaks to make it usable. We need to define how API root URL is defined. Here we found some structures that were still not allowed to be deserializable. And we need to add WebSys dependency for direct DOM access, only for the client side, of course. SerDQS is similar to SerDJSON. This is serialization and deserialization into URL parameters. We finally have it. Reducing context switching between languages and therefore removing extra people from the project is an obvious benefit of such languages as Rust. After trying a few Rust client-side frameworks, we stopped on a relatively new framework called Leptos because of its simplicity, performance, server-side rendering features, and similarity to React.js. However, we would not recommend starting with Cargo Leptos and server-side rendering features, and instead take a single-page application approach, just like typical React application. This means our Leptos application will produce just static files, and we will place it behind Nginx in our microservice. As installation requirements, we need three things. The first is a Rust target for WebAssembly called wasm32 unknown. The remaining two are command line utilities called trunk and wasm32 bint.jan CLI. You can quickly install them with Cargo. Log is a dependency to have login abstractions, and it will be for client-side only. You probably remember our habit of describing our plans in changelog files. In our app crate, there are some dependencies for console log and error handling. Chrono is for date and time manipulations. The main dependency is Leptos for client-side rendering with router. SerD stands for serialization, deserialization. And we will use business logic protocol crate, compiled with the CSR feature. As I promised in the beginning, there will be no focus on styling, HTML or CSS, but one of the tools that makes client-side development quicker is easier is Tailwind CSS preprocessor, which we will use in this demo. You just need to create a configuration file for it and correct path masks to match files written in Rust language. And the styling will be accumulated in the Tailwind CSS file. There will be just 3 typical lines. Index.html will be regular empty HTML with styles. The difference from simple HTML is data trunk attribute that we need to add to our target style sheets. And we also need special relation of Rust with 0 level of WASM optimizations attribute. Reactive application will be mounted inside of the body tag. There is additional trunk.toml file that we need to add. There are a few lines specifying what port the development server will listen to and what files should or should not be watched to trigger recompilation. This is it with our client-side application. Now we can run trunk.serve command to run our development server and watch the results in browser. However, we are not there yet, and you should follow the next final video where we deal with the aspects of code, patterns, and challenges of the Leptos framework.